Hello guys, our topic for today is neural machine translation using the encoder and decoder architecture. Starting off with what is neural machine translation. So neural machine translation is the use of neural network models to learn a statistical model for machine translation. And we have implemented this using the encoder decoder architecture, which has the ability to encode the source text into an internal fixed length representation called the context vector. Once encoded, different decoding systems can be used to translate the context into different languages. So for this architecture, we have used several RNN models. Um, we will look at some of the architectures which we have used. So firstly, we have the LSTM, which is a long short-term memory network, which is a type of recurrent neural network capable of learning order dependence in sequence prediction problems. This is typically used for machine translation, speech recognition, and other similar domains. Next, we have used a gated recurrent unit, which aims to solve the vanishing gradient problem, which comes in a standard recurrent neural network. The GRU can be considered as a variation of the LSTM network because both are designed similarly and produce equally excellent results. And finally, we have used a bidirectional RNN, which is basically just putting together two independent RNNs, and the input sequence is fed in time order for one network and in reverse time order for the other network. The outputs of the two networks are usually concatenated at each time step. So the data set which we have obtained is a delimited sentence pair which contains an English sentence and its corresponding German sentence. And so we have performed the following pre-processing steps: removing non-printable characters, removing punctuation characters, converting Unicode to ASCII, and converting everything to lowercase. This is typically because we would like to clean text data by removing punctuations and converting it to a form which can be read by the neural network and produce the best possible results. And here we can see the cleaned German to English sentence pairs without any punctuations or anything which will deter the performance of the model. Next, we have to build our encoder and decoder architecture. So one or more LSTM layers can be used for the encoder model. The output of the encoder model is a fixed size vector that represents the internal representation of the input sequence. The decoder must transform the learned internal representation from the encoder. One or more LSTMs can be used for the decoder model, and it reads from the fixed size output from the encoder model. So the problem here is we must connect the encoder to the decoder as they do not fit, because the encoder will produce a 2D matrix of outputs where the length is defined by the number of cells in the layer, but the decoder expects a three-dimensional input. So we can solve this by using the repeat vector layer. The repeat vector layer simply repeats the provided 2D input multiple times to create a 3D input. The repeat vector layer is used as an adapter to fit the encoder and decoder parts of the network together. The time distributed wrapper allows the same output layer to be reused for each element in the output sequence. So these are the model results. We have run 5 models with LSTMs, GRUs, and adding bidirectional wrappers to them. And we have also used a stacked LSTM layer, as several literature reviews have shown that stacked LSTM layers have obtained the best possible results. But in our case, we have only obtained 58% accuracy for a stacked LSTM layer. Next, we have evaluated our machine translation experiment using the BLUE score. So the BLUE score, or the bilingual evaluation understudy score, is a metric for evaluating a generated sentence to a reference sentence. A perfect match will result in a score of 1. An imperfect match will result in a score of 0. And these are, for our 18 test cases, these are the BLUE scores and the corresponding translations. Lastly, we have a chatbot demo which basically takes in a German sentence and also takes in the real translated the English sentence and for calculating the blue score, and it gives us a predicted sentence. As in the first sentence, we can see that it was um, the real translation was he was crying, and the model also translated he was crying, and so on and so forth.